it should be going. And I'm going to be making these all accessible again to everybody, even if you're not attending, because they're super important. Let me just add it to the playlist, and then I'll start talking. And let me also close my wife's door. Okay, sorry. Now I am ready to talk. Before I do, any questions or anything we have to go over? Anything we want to address before I jump into things? That's totally fine, Abraham. That's fine. And the lecture today you will find is much better for driving and just listening, so don't sweat it. Any other questions, comments, anything before I get going? Okay, so everybody, give yourselves a round of applause. We have finished out propositional logic. You've learned your first basic logical language. You've learned how to construct it. You've learned how to actually use it in argumentation. And hopefully at this point, you've taken your test, test 3 part 2, and you've done well. And if so, then you are a logician and you are, you know, a master of a new little language that you can use in argumentation. Good job, everybody. I mean, seriously, it does not, if you take this class, it probably does not seem like a big deal, but really it is. This is not something that most human beings ever accomplish. I'm serious. Like, it's just, this is not something that the vast majority of mankind has ever done. You are in probably 1% or less of the population of mankind, right? So welcome to the elite, the logical elite. There are people who know and are way smarter than any of us here, and like way smarter than me, better than logic. There is so much more rich philosophical, mathematical, and logical topics we could cover and we could get into. But this is a starting point. This is like you have jumped in and you're now a logician. You now know how to do logic, and you can build from here with other classes, or you can stay here if you don't need to worry about the topics, and you can just use what we've learned to think and argue more clearly in whatever field you end up going into, whatever your job is, right? So good job, everybody. I can't believe this semester is already almost over and we've gotten through this. But here's what we're going to talk about for the rest of the semester. How do we actually apply this, and how do we inquire into the truth? So far, what we've done is we have given a kind of a map or a model of a language that helps us think clearly, but only with complete certainty, right? So we have done so far deductive reasoning. Let me put it down here. I'm just going to say DD for deductive. And that has helped us get conclusions and arguments that conclusions follow from with certainty or with logical necessity. But as we covered at the beginning of the semester, deduction is just one kind of reasoning, right? You also have induction. And we looked at Hume's problem a little bit, so we didn't get too bored with truth tables. We looked at it a little bit early. But you also have induction, which has to do with probability, right? And if we're actually going to inquire into the truth, right, we're going to have to understand how to use both of them. So inquiry will contain both deduction and induction. I've taught you this entire logical system for using deduction, and I've barely even scratched the surface of induction, right? Now we have to spend the next few weeks remedying that. We have to take our focus off of pure deduction and learn the other half of inquiry, so we can actually approach philosophical topics approach research in any field, in science, in the humanities, and daily life, anything we inquire about, we're going to have to not just know deduction, we're going to have to look at induction too. And so let's start doing that. Okay, any questions before I start lecturing over the reading I sent everybody in assigned? Questions or comments? Nothing? Okay. So here's a little disclaimer. Unlearn, throw out, get rid of everything this book told you about inductive arguments. I taught to you at the beginning so you could get a rough idea about how inductive arguments work. But inductive arguments are not so naive as to go, I have my premises, and then, oh, the conclusion follows with probability, right? That's one thing we can do. But the whole thing of strength and cogency that we learned, those are kind of just like baby level oversimplifications that the book teaches you, because the book itself isn't really trying to get into this with much detail. Because what you're going to soon find out is that deductive logic was the easy stuff. Inductive logic is some of the most challenging stuff you will ever learn. I have been working on inductive logic for years on my own, trying to figure out how to make sense of it, but also how to develop an inductive logic, which has not been standardized yet. And it is seriously the most frustrating philosophical topic I have ever encountered. I hate it, but I love it at the same time. So all the stuff about an argument is cogent, an argument is strong, let's just forget that. Then let's start back from the beginning, right? Kind of like how I took you from the bottom up, from the basic deductive concepts to a whole system of proof. I'm going to take you from the bottom up with inductive logic, and we're going to learn the basics. Does that make sense? Kind of how we're approaching this? Okay, so again, deduction has to do with certainty. And when I say certainty, I'm not talking about psychological certainty. I'm talking about logical necessity, right? If those premises are true, if some data is true, then the deductive relationship is that it entails or implies some conclusion with necessity. Induction, again, has to do with probability, or as we will see, what might be the case, degrees of confidence, right? And I won't, that is an extremely complicated topic that I have read a lot about and still am very confused on, as with everything with induction. So I won't make that a big emphasis talking about what degrees of confidence are. I'm going to assume that we all kind of get what it means to say on some intuitive level, yeah, I'm like 70% sure that God exists. I'm like 90% sure that the sun's going to rise tomorrow, right? I'm going to go with an intuitive grasp of that. But deduction and induction are situated within this big process called inquiry. What is inquiry? Can somebody tell me? What is inquiry? If you've done the reading, or if you can just give me a common sense definition, what is that?
Like proposing questions.
Yeah, good. And Mason says the same thing, a question. It's when we inquire into something, we are asking a question, right? We are asking a question. What sorts of questions are we asking? If you're going to inquire into something, somebody give me an example of a question that you might ask, or the form of a question. Like what sorts of questions are we asking? Let's say I walk outside and I start my car, and it's directly from the reading, and the car doesn't start. What sorts of questions am I going to be asking?
why is it not starting? And then looking
Why
at
is it not starting?
solutions. Yeah.
Exactly. Good. So why is it not starting? I'm trying to find the truth about what makes it not start. The reason why it's not starting, right? So inquiry is just, let's just call it the pursuit of truth via or through question asking, right? The pursuit of truth through question asking. Now, obviously, if I walk outside, my car won't start and I start asking questions, this is not going to occur in a single moment of time, correct? This is going to be a prolonged process of seeking the truth by asking questions. And it might not just be one question, it might be multiple questions. And I'm going to go in stages over time. And this process of inquiry is going to unfold. So I'm actually now going to define inquiry as pursuit of truth via question asking over time, right? When we've talked about deduction, have we talked about time at all? Have we talked about the truth even, really? We've used the words true and false, but have we talked about how deduction and our deductive logic we've learned fits into a broader process of seeking the truth? We really haven't, because our entire language doesn't even say these premises are true or false. They just say we're going to assume they're true or false. And we're going to make a proof that, yeah, we do the proof over time. But once the proof's up on the board, it gives you this illusion that inquiry and reasoning is something that happens in an instant. Where in reality, inquiry, real pursuit of the truth, is something that human beings do in time, that unfolds over time, and ends up being a very messy, complicated thing, right? So all of the kind of the problem with teaching deductive logic first is that it gives you this very oversimplified view of reasoning and of truth seeking and arguing. It kind of makes you think like, if I just have this proof, I can get to the truth step by step. And then once I have it done, I can apprehend the truth all in one moment or all in one instance. When in reality, as finite human beings, as a type of animal, we are always in time, inquiring and discovering and learning and seeking and knowing the truth throughout time. It's a process, right? Inquiry is a process. I say this, I emphasize this because I had personally a hard time realizing this. I thought that everything could kind of be boiled down to these axiomatic truths that you then use deductive logic to get at. And you just, if we all understood the basics of physics and we're really smart, we could use deductive logic to just kind of deduce with proofs all of the theories of physics, right? It's just that I'm not smart enough to do it, or that I haven't thought about it hard enough. But that's just not how it works, right? It's not that oversimplified, idealistic deductive model. It's way messier. And we need to understand that if we want to understand how to be good philosophers, good scientists, good teachers, good historians, anything, good people that want to know the truth, even if you're not a researcher or a teacher, right? We have to open ourselves to the possibility that this stuff is messy. It does not fit into an easy model like deduction did. Okay. So we've got inquiry, pursue the truth via question asking over time. It's a process, a messy process. Okay, how do you inquire? Once you ask your questions, you're going to look for answers, right? Well, inquiry will precede answering these questions with theory. Theory is a broad term. It's normally in the United States used negatively to say that's just a theory, or to say you're just concerned with theory, not practical stuff. But what theory actually means is they are just different answers to questions, right? That we don't necessarily have direct knowledge of. So when you go through the process, we don't have to call it theory, we could call it the process of theorization. This is the process, again, in time, so it's going to be messy and weird and organic, the process of seeking answers to the questions we inquire through, right? Or we're inquiring about. So think of, you've got the truth out there. You've got reality as it really is. You want to know how reality is. You want to know the truth. So you inquire, you ask questions. You're trying to get at the truth through process of question asking. Within that process of question asking, you're going to have to start to come up with theories, which are answers to those questions. So hopefully, if we could answer those questions, we'll know the truth, right? That's how this works. And we can break it up into stages or little parts, like I'm doing inquiry, asking questions. Then part of inquiry is theorization. Now, part of theorization, right? What are the kinds of answers we're looking for? Does anybody have any idea? Let's say, again, I walk outside and my car won't start. And I ask, why won't my car start? What sort of question am I looking for? Or what sort of question am I asking? And what sort of answer am I looking for? If I ask, why won't my car start? What sort of answer am I going to be looking for there?
Cause.
Yeah, so we might say something like cause. Yeah, so what caused my car not to start, right? We could also say, what are the reasons why my car won't start? What made or what makes my car won't start? Or what makes it the case that my car won't start, right? Is that making sense? I mean, this should be pretty obvious, right? So let's do this. Nod your head if this is like, yeah, this is how I think already. I ask questions like this. And I ask what makes these things happen. Is anybody not following this at all? Okay. Okay, so the first part of theorization, we're asking these questions and we're coming up with answers as to what the cause was, what the reasons why are, what makes things happen this way, right? And we're going to put that under a broad head and we're just going to call it explanation, right? Explanation is answers to questions that answer things like why, what, how, right? Those sorts of questions. I call it in this reading theoretical explanation because sometimes explanation is more just like, can you explain what this means to me? Right? If I'm reading the Bible or reading a book and I'm like, can you explain this to me? I don't necessarily mean, can you tell me what causes the words to be this way? I'm asking for the meaning, right? Although I will say, as a promissory note, even meaning and interpretation is a type of theory. It's a type of theoretical explanation, but we'll put that off for now. I'll leave that to you to see exactly why that's necessarily the case, right? It's just a result of understanding this process more. Okay, so we've got theories that are explanations or explanatory theories or theoretical explanations, whatever you want to call them. The other thing we have are predictions. Okay, what types of questions could things like predictions answer? First, I guess, what is a prediction? Can somebody tell me what a prediction is? An educated guess. Yeah, that's true. A guess about what, Trevor? Sydney says, guessing what will happen in the future. Good, right. So it could be something like, what's going to happen tomorrow? If I do these things, what's going to be the result of that? It doesn't just, and Mason said the same thing, yeah, what may happen? Good. It doesn't just have to be about the future, though. It can be about the past. So you could say things like predictions maybe could be what will happen, or maybe even what did happen. And I think if you remember, here's a good way of thinking about this. And I'll say right off the bat, explanations and predictions overlap. I'm not saying that these are two completely different things. They're not. These are just two useful ways of dividing up the concepts to get really clear. But remember when we went back during the human problem and went to ancient Egypt and pretended to be an archaeologist, and we found a hieroglyph of a little man bowing before a cat, a big cat thing, which, if you remember, oh my God. Oh no, that doesn't look like a cat. What the fuck? I can't draw it. It keeps coming out like a penis. Oh my God, I can't draw. That's a cat. That's a cat. We saw a hieroglyph of a Egyptian man bowing and worshiping this cat. And we came up with a bunch of what? Theories? A bunch of explanations for why this hieroglyph is here and what it means. But in a sense, that's also a prediction because we're predicting how the past really was. What happened that leads the Egyptians to make this artifact, right? So explanations are answering why, what, how questions. Predictions are saying what will happen, what did happen, or maybe even what is happening right now that I can't see. And the notion of prediction that kind of ties this all together is that predictions are guesses or attempts to get at the truth that's unobservable. So I can say guesses at unobservable truth. Now, maybe there's a truth to the matter about what will happen tomorrow. Maybe there's a truth to the matter about what happened in the past or what's happening right now that we can't see. But the point is that prediction are guesses at unobservable truths or truths we don't currently know and can't directly observe. And we're trying to figure out what's true that we can't just see right in front of us, right? Can you see the future right in front of you? No. Can you see the past? No. The past is gone. Can you see what's happening on an atomic level? No, not without a microscope, an electron microscope. Can you see what's happening in China right now? No, right? So to get at these unobservable things, we have to make predictions. Predictions are not just guesses about the future, but guesses at more broadly what is unobservable or what we do not currently know, right? So theory encompasses two things: explanations for why, what, and how the way things are the way they are, and predictions, which are what is the truth that I can't exactly confirm with my eyes or senses. How can I guess and apprehend and know what's really true unless I could directly observe it, right? We use explanations and predictions to do that. Any questions so far or comments on the general structure of these things, of what I'm saying here? Okay, I can say kind of a meta remark at this point. The point of me teaching you this is because you're supposed to be in here learning how to critically reason and think. This class is supposed to be preparing you to be a nurse, a doctor, a biologist, a lawyer, a philosopher, a pastor, a mother, a father, a boyfriend, a girlfriend. This class is supposed to be shaping who you are and how you think. And we're trying to train you how to think clearly and well. And how are you supposed to think clearly and well if you don't even know how to get at the truth, how to discover the truth? If I just taught you deductive logic, you would never know how to get at the truth. You would just know, yeah, if I knew the truth, I could play around with a logic game and maybe deduce some things from it. But you never end up actually being able to understand, how do scientists reach the theories and conclusions they do? How do historians reach the historical theories that they put forward and we read about? How do we know that I don't know, this hieroglyph indicates that in the past, Egyptians worshipped cats or whatever. If you can't answer those questions, then how are you ever supposed to pick a major and actually do work in the major? The real answer is you get really lucky that human beings kind of have this ingrained on an intuitive level and do this. And you get lucky when you go into a church, not a church, a school or church mentorship program, and they teach you kind of the tools of the trade in an intuitive way. They don't teach you this explicitly, but you learn this through trial and error. But how much better would it be if you could learn the general framework for this of method directly, and then you work out the details later, right? It would save you a lot of time. I spent so many years trying to figure this out. So anyway, that's kind of why I'm emphasizing this. You've got method here. This is a study on method. And it's actually going to be a study of universal method. Method in all human disciplines, not just science, not just philosophy, but everything. So how these disciplines proceed, how humans inquire, asking questions, pursuing the truth through asking questions, then you enter theorization. And you say, okay, I now have to engage in the process of, I'm going to look for answers to these questions. And the two forms answers come in are explanations and predictions. And those overlap again. Any questions or comments on the general structure of what we're talking about? Okay, so moving on from that. Can somebody tell me what a theory is in terms of an explanation? What is an explanation? And don't just repeat back to me what I said. Don't just say it's an answer to why, what, how questions. I want you to actually tell me what that means. What is an explanation or a theory? How does it work? I'll put the question on the board. What is an explanation?
The book says a story that makes sense of something puzzling. Or the
Sure, it's a story. Yeah, it's a story that makes sense of something puzzling. That's good. Yeah, it's an answer to those questions we ask, that when we're puzzled, about some event, we ask those questions like why, what, how, and we tell a story that helps us not be so confused or understand why they happened. Good, right? Exactly. Okay, how does that work though, Shelby? And don't just type me the book. Tell me, like, again, how can you explain to me how we do that? If you do it all the time, shouldn't you be able to do it? Right? I think we do. I'm just going to assume all of us do this all the time. But how can anybody explain to me how that works?
I guess just like reasoning in your mind. I don't know. I'm not sure.
Sure.
I don't know how to
reasoning
explain
in
it.
your mind. Right. Reasoning in your mind. Is it going to be deductive, like logical reasoning, like we've been learning? Does that get you anywhere to learning the answers to questions? I don't see how it could, because it's purely hypothetical. If these premises are true, here's what follows, but it never tells you these premises are true. It never tells you how to deal with probability or things that you don't already know and can prove, right? So I don't see how that would work. So we know explanations answer those how, what, and why questions. Shelby gave us the definition that I think is accurate, that an explanation is a story, or we can even say a set of considerations. Super vague. What is a consideration? Could be many things. Could be facts, could be laws of nature, could be different value statements, could include anything. And events, I don't know, could be a lot. So it's a story, a set of considerations which shed light on some puzzling event, right? Okay, so we've got two things, a set of considerations and a puzzling event that we want to make sense of. An event puzzles us, like we walk outside and suddenly our car doesn't start. And we want to know why it happened. So we ask that question, right? How do we then answer the question, why is this happening? Well, we tell a story. We tell a story about how maybe the battery is dead. And if a battery is dead, then the car's not going to start. Or we tell a story about how, well, the battery's actually not dead, but rats chewed through the battery cables. That the rats chewing through the battery cables means that the battery's disconnected, so the car's not going to start, right? There's two different stories I just gave, two different theories or hypotheses that I gave that make the puzzling event, that would make sense of or shed light on the puzzling event, right? That would answer the why, what, how questions, right? Does this make sense to everybody? We're talking about an explanation of the story, a set of considerations which shed light on some puzzling event. Gabrielle asks a brilliant question. Are theories or hypotheses a part of the set of considerations? They can be. We'll get into this later. I don't want to confuse anybody, but Gabrielle, let me see if I understand your question. Are you saying that sometimes we already have a theory or hypothesis that we believe or think is probable, and then we use that to then explain something else, right? It itself becomes part of the story. Does that make sense? Is that what you're asking, you think?
Yeah, like like in the book, I guess it kind of confused me, but like in person, it makes more sense. Like the rat chewing method could be like a hypothesis, and then would that prove the explanation if it was true?
So very close. Let me disentangle these things real quick. So let's just say that we've got our set of considerations, or our story, right? Let's just say I list these things out. Let's just say I say consideration 1, consideration 2, consideration 3, and then down here I'm going to put an arrow. This is just my way of symbolizing it. I'm going to say all of those considerations, this whole thing is the story, right? The considerations are all parts of the story. That explains the puzzling event, right? My car won't start. Oh, come on, right pencil, puzzling event, right? That arrow just means explains. So let's say I have my set of considerations 1. We'll just say the puzzling event is car won't start. 1, rats chewed the cables. If rats chewed the cables, then car wouldn't start, etc. Right? We don't have to fill in 3. But the whole thing, all the considerations taken together are the story, or also called the explanation, or the hypothesis, or the theory, right? Does that make sense? The whole thing taken together. Now, let's say that a couple of years from now, my car doesn't start again. And I know last time it happened, it was the rats. Well, I can take my previous theory and now add it in as part of these, right? I could say the theory was true before or something like that, right? And so now my old theory becomes part of the new theory. So they can kind of stack, they can accumulate. And old theories can be parts of new theories, like Lego blocks, like building blocks, right? But if we're just going super simple and just saying 1 and 2, the theory or the hypothesis itself is just the set of considerations. The events, the laws of nature, the rules for how a car works and starts, those are all going to be the theory. And I'll just call it H for a hypothesis, right? Does that make sense, Gabrielle? So the whole thing is a hypothesis. Okay. All right. So we've got, in terms of the language of the book and a lot of older books, which I think is a little bit outdated, but I still got to teach it. You call the puzzling event an explanandum, which is Latin, and it's just thing to be explained. And you call each part here part of the explanans, or not part of the explanans. You call each of these parts explanans. Right? We could say explanans 1, explanans 2. If you don't want to use that language, it's fine. I don't normally do it in my work unless I have to. You could just call these, explanatory considerations. 1, rats chew through the cable. 2, if rats chew through the cables, then the car won't start. And that leads me to predict the puzzling event or understand why the car won't start. Any questions on this, the structure of explanation? So let's generalize back out from this. Let's say that now we understand that explanations are stories. They're sets of considerations which shed light on some puzzling event. I could give them this structure. Let's just say explanans 1, explanans 2, however many others we have, and then they explain or lead us to predict the explanandum, right? The puzzling event. The set of all these explanans or the considerations are the hypothesis or the explanation or the theory, right? A theory is not just a single thing. It's a story. That's what I'm getting at here. And that story is making sense of the puzzling event. So I give it that structure. The whole story, all of its parts listed, make sense of or shed light on the puzzling event, the explanandum. That's how I think explanations work. That's the structure. Questions on that? What is an explanation? The structure of explanation? Okay, so let's talk real quick about explanation. It seems like explanations are just arguments, right? From the one I just gave, they look like a deductive argument. If rats chewed through the cables, and if rats chewing through the cables would make it so the car doesn't start, I know rats chewed through the cables, therefore I know the car won't start. That just seems like a straightforward syllogism, right? A deductive argument. P then Q, therefore Q, right? The thing is, yeah, there's overlap here. This looks kind of like an argument. There's logical relationships, but it doesn't have to be a deductive argument like that. It doesn't have to have deductive certainty. We are starting from the place, let's just say, of a present observation. Right? We're moving from a present observation, a puzzling event, and we're trying to reach up and reconstruct why it happened. Right? And maybe we could say it's an unobservable past or causal story sequence that made the present observation happen. Okay. We're trying to go from what we see in the present to what's in the past, why it happened. Now, there are tons of explanations that do not just fit into argument form. Here's one of them. One, I have a penny. Let's just say a penny P, which has a bias 90% of the time towards heads, right? Do you get what that means? It's kind of, maybe it's a little bit warped or bent. 90% of the time I throw that penny up, it comes down in its heads. So if I'm going to play heads or tails and I guess heads, I'm going to have a pretty good shot of winning, right? So I have a penny P, which has a bias 90% towards heads. Two, let's just say I tossed the penny. Now my puzzling event is this. How do I explain why I got tails? How do I explain why I got tails? If I say, let's say exponens 1 is that I have a penny where that 90% of the time it's heads, and exponens 2, I tossed that penny and it landed on tails as a puzzling event. How do 1 and 2 explain I got tails just now?
Because tails is still a possibility.
Right, good. Tails is a 10% possibility. Mason said it too. There's always a 10% chance, right? So built into this, even though it seems like I'm just talking about the heads, I'm really saying, okay, look, I threw this penny, explains 2, and there was a 10% chance that it was going to land on tails. The fact that I tossed the penny and the penny had a 10% chance of landing tails is an explanation for why I ended up getting tails. It makes sense of, it's a story. This whole thing here is a story that makes sense of the explanandum. I got tails, right? Does that make sense? Nod your heads if that's making sense. Okay. Now let me ask you this. If I put this in an argument form and I said P will land tails 10% of the time. 2, I toss P. Therefore, P will land tails. Is that a good argument? Is that a strong argument? No. No way, right, Mason? Right, Trevor? Yeah. Because it's saying essentially, I guess phrase this another way, there's a 90% chance that it's not going to land tails. I throw it up in the air, therefore it must land tails. That doesn't make any sense. Wouldn't the argument be better that the conclusion was it's not going to land tails, it's going to land heads, right? So we put 90% of the chance not tails. What this shows you is that explanations are not arguments. They don't have to be, right? This is an argument. This is an explanation. In order to shed light on something, in order to say why something happened, we don't have to say, we don't have to basically give an argument for why it had to happen. Because some things happen, but they probably weren't going to. They had a low probability, right? But they still happened. And so we're not going to expect to give an argument that would say, this is why this exactly had to happen, right? So explanations are not arguments. I won't go too much more into that. So let's return to this slide and look and reconsider. When I say it's a story, I am not saying that it's a deductive argument. You are not going to be able to put it into premise conclusion form and do a proof on it. I'm talking an explanation is a different sort of thing than what we've been learning about. And that's why we have to study this separately. It is a story, a set of explanans, right? Which shed light on some puzzling event. Let's say these are the explanans. That's the explanandum, right? That's the nature of an explanation. Any questions? All right. Well, here's where it gets tricky and where we'll pick up next time. What does it mean to make sense of or shed light on a puzzling event? That is, I've given you the structure of explanation. I have not told you how it's really working. It's not an argument, but then what is it? What does this arrow right here represent, right? How does this story make sense of why this puzzling event happened? What does that mean, right? We'll talk about that more. And it's a more complicated issue than it first seems. This is an extremely complicated issue. So we'll talk about this a little bit more. We'll kind of do surface level introduction. I think it should be good enough to prepare everybody for actual life and even research. But yeah, any questions? We're out of class time, but I can answer some questions. Questions, comments, concerns? Okay, so just remember this. I'm teaching you about inquiry, process of seeking truth through asking questions. How you do that is theorization or theory, answering these questions with either explanations or predictions. Now we're looking at, well, how do we do that? Here's what an explanation is. It's a story, a set of considerations which shed light on some puzzling event. Here's a structure of explanations. It's a list of explanations of considerations that would in some sense explain the explanandum. I'll cover prediction next time and kind of summarize this, and then we'll get into more details on two things. What's the relationship between the story and the puzzling event? What's it mean that it sheds light on it? And how do we know that our preferred theory or explanation is actually the right one? How do we know? That's a big topic, right? How do we know which story is true? Maybe we're just making them all up. Okay, I'll see everybody next time. Take it easy. Have a good day. Seriously, read this assignment. And if you don't read it, then you won't be able to do the homework packet because the homework's in this thing, right? In this booklet.